Dipole-dipole forces. These interactions occurs in polar molecules having permanent dipole. Okay? Polar molecules having permanent dipole. Examples: HCl, H2S, then HBr, etc. HCl, HBr, H2S, etc. These are polar molecules. Okay. Now the molecules possess this partial charges of opposite sign at their two ends. Okay, and which is denoted by the letter delta. So if we take example HCl, there will be a partial negative charge at one side and partial positive charge at other side. Okay, partial charges will be developed at the two ends and it is denoted by the letter delta. Okay. Now the positive end of one molecule attracts the negative end of the other molecule and vice versa. For example, if we take HCl. Okay, HCl. Here chlorine is more electronegative, so it gets partial negative charge, and hydrogen is electropositive and it gets a positive charge. So the nearby atom will there also a charge is developed. Okay, so the opposite sides of the two atoms attract each other. Okay, of these two molecules, the opposite sides attract each other. As a result of this, a dipole is developed. Okay, this dipole is known as dipole-dipole forces. So dipole-dipole interaction occurs and this force is known as dipole-dipole forces. Okay, so these partial charges are always less than the unit electronic charge. These partial charges are always less than unit electronic charge. The value of unit electronic charge is 1.6 into 10 raised to minus 19 coulomb. Okay. So this partial charge will be always less than this unit electronic charge. Next, these forces are stronger than dispersion forces or London forces. Okay, these forces are stronger than London forces. Next point, the attractive force decreases with increase in distance between dipoles. Okay, attractive force decreases with increase in distance between the dipoles. Next, this interaction energy obtained during this dipole-dipole forces is inversely proportional to the distance between these polar molecules. Okay, interaction energy is inversely proportional to the distance. So there are two cases. First, for stationary molecules. In the case of stationary molecules, this interaction energy is inversely proportional to the third power of the distance between the molecules. Okay. Next, for rotatory molecules. In this case, the internal energy is inversely proportional to the sixth power of the distance between these molecules, these polar molecules. Okay. Now, besides this dipole-dipole interaction, polar molecules also possess London forces. Okay. So, polar molecules also possess London forces along with this dipole-dipole forces. So, the cumulative effect will be the total of these intermolecular forces. So, the intermolecular forces of polar molecules are increased. Okay, intermolecular forces of polar molecules are increased because in this case there will be a total effect. Both dipole-dipole forces and London forces are there in this case of polar molecules. Okay.